Welcome to the session, students. So in this session we will see about sampling and quantization. As you all know, sampling and quantization is one of the most repeated and interesting topic in our department, right? So in this session, let's see how sampling and quantization plays a major role in digital image processing. Okay, so completing this topic, you will be able to explain what is sampling and what is quantization in an image. Okay, so now let's get into the session. So to know in depth, I have taken an example of sampling and quantization images. Okay, so first I have taken a continuous image. So before that, now let's see what is sampling and quantization. Okay, so I'm going to convert this particular continuous image in form of digital. So for converting that, we are going for using two process called as sampling and quantization. Okay, so sampling nothing but it will be referring to the discretization of spatial coordinates, and whereas quantization will be referring to the discretization of grade level. Okay, so this is the difference between sampling and quantization. Okay, so in case of sampling, we will be discretizing the image in the spatial coordinates, right? So this process of discretizing the image along the gray values is said to be sampling. Okay, so by applying this method, we are converting in the form of digital. As you can see that in the left side, you are having some continuous image, analog image. Okay, so whereas in the right side, we are having the digital image. So it is represented in the form of pixels, where n and m are usually the integers. Okay, so before that, let's see, there are numerous ways to acquire the image. Okay, so before sampling and quantizing, what is the first process that we have to do? First, we have to capture an image. Okay, so in technical terms, the capturing of an image is called as acquiring images. Okay, so we are acquiring the images. Okay, so and then after that, we are acquiring in the sense we are sensing the image. Okay, so the output of the MOVE sensor will be a continuous voltage waveform whose amplitude and spatial behavior are related to the physical phenomenon being sensed. So to create a digital image, what we will do, we have to convert this sensed input data into digital form. Okay, so that particular process is called as sampling and quantization. So you can understand it very clearly from this given example. Alright, so we have taken a continuous image, and now what we are doing, we are sampling and quantization between the line A and B. Okay, so in this continuous image, we can see that there is a line segment dividing that analog image. So we have taken that particular space between A and B, and we are scanning from A to B, and then we are sampling and quantizing that particular image. Okay, so it is being quantized. As you can see that we are marking the peak levels, that is the gray levels, and finally in the digital scan line we have obtained the gray levels. Okay, so you can see that the marked from darker gray level to the lighter one. Okay, so depending upon the pixel values or the gray level values, we have converted in the form of digital. Okay, so this is how the sampling is being done. Okay, so as I explained to you earlier, so here we have again seeing about basic concepts in sampling and quantization. So we have taken a continuous image A to B. It is taken along the coordinates x and y coordinates and along in amplitude function. So to convert it in the form of digital form, we have to sample it in along both the coordinates as well as in the amplitude. So digitizing the coordinate value is called as sampling. In simple terms, we are saying that digitizing the coordinate values is called as sampling, whereas digitizing the amplitude values is called as quantization. I think now you might have gotten clear-cut idea about what is sampling and what is quantization. Okay, so the one-dimensional function is a figure of plot of amplitude. As I told you earlier, we are just mapping it on the gray levels. Okay, so there may be some noise added due to that noise in the image. So due to that noise present in that image, there is some random variations along the graph. Okay, so you can see that a scan line from A to B in a continuous. Okay, so sample points are indicated by vertical tick marks at the bottom of the figure. as you can see there. Okay, so samples are given in the squares that is superimposed in the function. That is, you can see, we are marking with small square box along the analog function. Okay, the set of these discrete location will give the sample function. So to form a digital function, again we are converting the intensity values to the quantized discrete quantities. So the right side of the figure will be showing the intensity scale. I told you, it will be varying from darker shade to lighter shade. So that is called as the intensity gray level, and it will be ranging from black to white. That is different gray levels. Okay, so now the continuous intensity levels are again being assigned one of the 8 values to each sample, and the assignment is made depending upon the vertical proximity of the sample to a vertical tick mark. Okay, so the digital sample resulting from both sampling and quantization is shown here. Okay, so this is the input image, and this is the result of sampling and quantization. Okay, so the second figure you can see clearly how the image is obtained after sampling and quantization. Okay, so the quality will be defined only by the degree of number of samples and as well as the number of discrete intensity level that is used in sampling and quantization. Okay, so now it's up to you students. So try to answer this question, that is, you have to list out the difference between sampling and quantization. I hope you all had a useful. Thank you for watching this session. Thank you.